Welcome to this session on drilling optimization focused on execution to control. This is submodule 4 of 4 in our drilling optimization training. In this module, we will examine how risks are managed, how optimization opportunities are identified, and how engineering workflows are integrated to improve drilling performance. In this module, we will focus on 5 main objectives. First, we'll understand the key drilling risk indicators and explore strategies to mitigate them effectively. Second, we'll identify the main performance limitations that appear during execution and learn how to turn those into optimization opportunities. Third, we'll apply multi-well engineering analysis by linking geoscience and well data to identify correlations and improve performance. Fourth, we'll see how workflows can be integrated across planning, execution, and learning cycles to create a continuous improvement loop. And finally, we'll recognize the impact of drilling optimization in terms of tangible business value, improving return on investment and lowering overall costs. Together, these objectives provide a comprehensive framework for managing execution in real time while ensuring control and consistency. Optimization begins with analyzing execution performance limitations. Every drilling system has inherent limits, whether mechanical, hydraulic, or operational. The first task is to identify where these limits appear, such as maximum rate of penetration due to bit wear, restricted mud circulation, or reduced tool accuracy at greater depths. Once limitations are defined, engineering methods can be applied to avoid or reduce their impact. For example, optimizing weight on bit and rotary speed can reduce vibrations, while managing mud rheology helps avoid poor hole cleaning. Engineering models enable us to simulate what-if scenarios, so we can design around these limits before they result in downtime. Accuracy plays a critical role here. Data must be validated and measurements verified. Without accuracy, optimization attempts may simply reinforce incorrect assumptions. The slide highlights the movement from understanding limitations through engineering solutions to ensuring precision. It reminds us that optimization is not about pushing equipment beyond its safe design, but rather aligning parameters so that each variable operates at its most effective point. In top left picture, the color coding is rate of penetration. What you can see is that for a given depth, ROP is highest when standpipe pressure is highest. This could indicate the bit nozzles could be optimized for better HSI. Having explored optimization within a single well, the next slide takes us into multi-well engineering analysis, where data correlations multiply the opportunities for improvement. Multi-well engineering analysis leverages data correlations across multiple domains. Instead of analyzing wells in isolation, we connect variables to uncover patterns that guide optimization. This process begins with geological and geophysical logs, which provide context on formation pressures, rock strength, and lithology. Here we emphasize the cycle of learning, validating, and orchestrating. Learning begins with the data collected during drilling, lessons from both successes and failures. Validation ensures that these lessons are not anecdotal, but supported by evidence, simulations, and cross-discipline review. Only when results are validated do they become reliable inputs for future projects. Orchestration refers to how these validated lessons are applied. In practical terms, this means embedding insights into workflows, drilling programs, and decision-making processes so they are systematically used rather than left as isolated knowledge. The diagram on this slide shows the connected elements, automated design tools, validation through engineering applications, and an integrated learning loop. This structure ensures that each phase of drilling contributes to the next, creating a cycle of continuous improvement. The important message here is that optimization is not a one-time event, it is an iterative process. By learning, validating, and orchestrating, companies can reduce variability between wells, improve execution quality, and increase predictability in outcomes. This naturally transitions us to the integrated workflow, where inputs from different domains flow into planning, execution, and learning in a continuous loop. The integrated workflow ties together all domains, geoscience, drilling, completions, and production into a connected process. Inputs include basis of design, well programs, and cross-discipline data. Execution follows these plans, and outcomes are fed back into the learning cycle. G and G in context reminds us that geology and geophysics are not standalone. They directly shape drilling design choices such as casing points, mud weights, and well paths. A plan scenario optimizer then evaluates multiple cases, balancing risks, costs, and technical feasibility. The workflow also incorporates multidimensional engineering, which combines sensitivity analysis with continuous learning. For instance, stress tests can simulate pressure loss events while offset well reviews refine bit selection. The diagram illustrates this workflow. At the top, inputs from other domains feed into the basis of design. These then flow into the well program, execution, and eventually into structured learning. The cycle ensures that planning and operations are dynamically linked, creating a feedback system that improves efficiency with each well drilled. The key message is that optimization requires integration. No single domain can achieve it alone. This sets the stage for the infinity loop model, which visually represents how plan, operate, record, and learn form a continuous cycle. Here we introduce the infinity loop model, a powerful way to visualize continuous improvement. The loop consists of 4 connected actions: plan, operate, record, and learn. Planning sets the baseline by defining objectives, risks, and strategies. Operation executes the plan, applying drilling parameters, workflows, and controls in real time. Recording ensures that data is captured accurately, from surface sensors to downhole measurements. Learning closes the loop by analyzing outcomes, identifying what worked well and what requires improvement. The diagram, shaped as an infinity symbol, it illustrates how these 4 steps flow seamlessly into each other. There is no fixed start or end. The process is perpetual. The significance of this model is that it prevents knowledge from being lost between wells. Each new operation benefits from the lessons of the previous one, and the cycle ensures continuous refinement. This is particularly valuable in complex fields, where variability between wells can otherwise cause cost and time overruns. From here, we extend the infinity loop into practical tools. Next is a short video on drill plan and drill ops, which operationalize this continuous improvement cycle within an integrated digital platform.
SLB is transforming the well construction lifecycle from planning to execution, utilizing collaboration and automation, whilst integrating the untapped power of data and AI to create a seamless loop between town and rig, making every well better than the last. That starts with our cloud-native drill plan coherent well planning and engineering solutions, proven around the world to produce superior quality drilling programs in half the time. Next, DrillOps Intelligent Well Delivery and Insight Solutions provide smart automated workflows and autonomous operations to improve consistency and optimize performance. At the heart of drill plan solutions are 4 key principles: automation, validation, collaboration, and coherence. Its single point of data entry and collaborative environment automate repetitive tasks, reducing manual errors, while automated engineering analysis run multiple sensitivities concurrently, reflected in real-time changes across the whole system. This ensures coherency across teams and service providers, giving engineers more time to act faster and smarter, enabling optimized, cost-efficient, and more sustainable well designs. Those designs are seamlessly passed to DrillOps, where AI-driven automation and advisory applications enable intelligent execution, delivering unprecedented performance and consistency, while also significantly reducing carbon emissions. Our advisory solutions can be deployed immediately on any rig, providing drillers smart recommendations for drilling and tripping execution. Connecting rig to town, DrillOps Predictive Analytics provides real-time decision support, unifying industry-leading domain models with AI to help predict and prevent drilling events, reducing risks, and improving performance. Throughout, daily activities and lessons learned are captured to deliver a data-driven, automated record for input into future operations and planning. With SLB, you're covered from planning to operations with solutions that optimize efficiency and performance, all to make every well better than the last.
Optimization creates value through two main levers: risk management and clean time optimization. Risk management focuses on incidents, detecting them early, preventing them from occurring, mitigating their impact, and even predicting them before they materialize. Effective risk control decreases the probability of costly failures and reduces the impact on both time and spending. Clean time optimization, meanwhile, addresses efficiency. It begins with detecting opportunities, analyzing their potential, and then implementing process improvements. Through continuous process control, companies can decrease costs and maximize return on investment. Key performance indicators, such as rate of penetration, non-productive time, and drilling efficiency, provide measurable evidence of these improvements. The diagram shows how clean time optimization is at the core of risk management as the wrapper. Risk management lists the chain of incident control measures, whereas clean time optimization emphasizes performance metrics and process improvement. Together, these highlight that optimization is both defensive and offensive. We avoid unnecessary losses and we actively capture efficiency gains. The message here is straightforward. Optimization is not just about technical performance, but about financial outcomes. Reduced risk and improved efficiency directly contribute to higher profitability. The teaching of drilling optimization is fundamental to the performance ethos, which has delivered the long-term success of integrated project management with SLB. To close the course is a short on IPM, celebrating its 30-year history within the industry.
In July 1995, a new chapter in SLB's history began. Our customers were telling us they needed more than services and product delivered in a traditional fashion.
So we created a brand new segment for the market, Integrated Project Management, to deliver superior performance through the integration of industry-leading workflows, risk management, technology, and aligned commercial models.
Today, 30 years from inception, we operate more than 100 rigs worldwide and maintain over 50 active projects at any given time across 5 continents.
We've been the partner of choice for 350 operating companies in 92 countries, where we have 20% fewer injuries, drill 50% faster, and produce barrels with 20% less carbon intensity versus previous benchmarks.
By leveraging the broader SLB resource pool and harnessing the expertise of more than 1,200 petrotechnical experts, project managers, and commercial teams, we have created a unique industry offering through cross-discipline collaboration and specialized knowledge in managing projects.
Whether in HSE, operational integrity, drilling, or production, our fully integrated model enhances both operational efficiency and financial returns for all stakeholders.
We cover the entire E&P cycle end-to-end, and we are creating new offerings for CCUS and geothermal to contribute to balanced energy demand for the future. We are enabling digital transformation across the drilling and production space, deploying smarter, faster, and more adaptive workflows to augment performance.
Our dedication to excellence remains as strong today as it was all those years ago, and we're committed to delivering value to our customers as sustainable as possible across all operations.
30 years into this remarkable journey, we are even more excited to deliver outstanding results for our customers and SLB going forward. The best days for SLB integration are still to come.
Let's revisit the objectives we set out at the beginning of this sub-module. First, we aim to understand key drilling risk indicators and mitigation strategies. We've done this by reviewing real-time monitoring, risk calculation, and incident control. Second, we set out to identify performance limitations and opportunities for optimization. This was covered through execution analysis and engineering methods to overcome constraints. Third, we applied multi-well engineering analysis, showing how G and G data, well schematics, and production information combine to identify correlations and best practices. Fourth, we looked at integrated workflows across planning, execution, and learning cycles. The Infinity Loop and Drill Plan/Drill Ops platforms illustrated how this cycle is operationalized. Finally, we recognized how optimization translates into business impact, improving ROI and reducing costs through risk management and clean time optimization. Together, these objectives form a framework that enables consistent, efficient, and profitable drilling performance. That concludes Submodule 4 of 4 on Execution to Control. It also concludes the course on Drilling Optimization. It has been a pleasure to walk with you on this journey. You should now proceed to the short quiz to reinforce what we've covered and check your understanding. Thank you for your attention and active participation. I hope the concepts we discussed will support your future drilling projects and optimization initiatives.